Thanks for making it the Russell Institute. Today we're going to be talking about cells and batteries. Cells and batteries. And so what cells and batteries do is they produce electrical energy. Cells and batteries, actually, they convert energy. They convert energy from its chemical form. They convert chemical energy to electrical energy. Right now, if you guys are familiar, you will know that energy cannot be created nor destroyed. It can only be transferred from one form to the next. So cells contain energy in the form of chemicals, and then they convert it to electrical energy. And so we're going to look at what we call the schematic symbol. We're going to look at the schematic symbol of a cell. Now, the schematic symbol of a cell is one long stroke and one short stroke. Now, the long stroke represents the positive side of the cell, while the short stroke represents the negative side of the cell. Now, what does that really mean? Well, what it means is if I am to connect this thing and make an entire circuit, if I'm going to make an entire circuit, it means that the current, which is what we call electricity is going to flow from the positive terminal, from the positive side of the cell, and it's going to go all the way around to the negative side. So electrical current flows from positive to negative. And that's always the case. Electrical current will flow from positive to negative. Now, what's interesting about a cell is that it has what we call a nominal voltage. The average cell has a nominal voltage of 1.5 volts. All right, so your cells will have a nominal voltage of 1.5 volts. So what does this mean? This means, for example, when I put them together, when I put cells together, we create what we call batteries. When we put cells together, we create what we call batteries. So here I have two batteries, right? And so they're basically cells connected in series. And so here, in this first example, I have one long stroke, two long strokes. So I have two cells put together. And if I have two cells put together, if I multiply 2 by the nominal voltage of 1.5, I'll realize that what I really have is a 3-volt battery. I have a 3-volt battery. And if I connect both ends, the current is going to flow here in this anti-clockwise direction, because it's going to start at the positive side and go to the negative side. And let me just remind you guys by labeling the long stroke. The side with the long stroke is positive, and the side with the short stroke is negative. Now let's look at the second example down at the bottom left here. So let's see how many long strokes I have here. I have 1, 2, 3, 4, 5 long strokes. So if I have 5 cells connected to make a big battery, and 5 times 1.5 is 7.5. 7.5 volts. So this battery is a 7.5 volt battery. And if I'm going to connect both ends of the battery, which way would current flow? Well, let's remember, our positive side of the battery is the one where there is long stroke. So this is the positive side. And our negative side is the side where there's a short stroke at the end. So that's the negative side. And current is going to flow from positive to negative. So in this case, the current is now going to flow clockwise. The current is going to flow clockwise. Alright, and so we have a 7.5 volt battery and the current is flowing clockwise. So my final question is, how do we draw the battery of a cell given its voltage? What if I wanted a 10.5 volt battery? How would I go about drawing that? Well, I need to know how many cells make 10.5 volts. And so we're going to divide that by our nominal voltage of 1.5 volts. And we should get 7. We should get 7 cells. 7 cells means 7 long strokes, 7 short strokes. So let's go 1, 2, 3, 4, 5, 6, 7. All right, let's double check. That's right. 1, 2, 3, 4, 5, 6, 7. All right. Positive side is going to be where the long stroke is. Negative side is going to be where the short stroke is. And there we have it. This is how you draw a battery. So to review, a cell converts chemical energy to electrical energy. It has a nominal voltage of 1.5 volts. Current flows around the circuit from positive to negative. Now a battery is multiple cells combined together. And based on the number of cells, you can just count the number of long strokes and multiply it by 1.5 and you will get the voltage of the battery. Thank you for making it the Russell Institute. Don't forget to leave a like or subscribe for a chance to win free Digicel or Line credit.